So we're in section 1.4. We're going to talk about rays and angles. And let's put our electronics away, please. Put it away. So let me bring up my first slide here. And we'll fill in our first definition. You'll need other people. So our technical definition, so electronics, let's put them away. Our ray, our technical definition, ray is that first one, part of a line that starts at a point and extends infinitely in one direction. So that first line is going to be our technical definition. And we'll draw a picture here also. So this first one's our technical definition. Here would be our picture. And I'm going to say I'll use the same. So this is where we start, and it extends in one direction. We call this point the end point. So that would be one of your facts or characteristics. The point is called the end point, or you could put it in your picture. And it's kind of interesting that we call it the end point, even though we think of that as where the ray starts. But that's just how they did it. So this would be our picture of our ray. Factor characteristic starts at the point called the end point. We name it using the end point. Another factor characteristic, we name it using the end point and one other portion one other point on the ray. So this point R is on the ray. And so we're going to name this ray M R. And we put a one-sided arrow over our capital letters, the end point, and the one other point on the ray. And we want the ray, our letters, to go in the same direction with the letters that it goes on the actual ray. So if it helps you to remember, draw your end point there by point M, so it reminds you to line up the end point with point M. We could also name it this way, but if we named it this way, we'd want to put our ray going that direction. So our points and our arrows have to line up in the same way on the ray and the way we name it. They have to be the same. So there's our name of our ray. Examples of a ray. You can come up with your own. I tend to think of a ray. One way is to think about like the beam of the flashlight. So the end point would be the flashlight, and the ray would be the light shining out. So this kind of extends infinitely in one direction, but eventually we can't really see it. So that's one way we can think of a ray. A really long, maybe like the path that an airplane takes in the sky is like a ray. It's really, really long, but it goes in one direction. So those would be examples of some everyday examples of a ray. The definition in your own words. You should come up with your own definition, how you think of a ray. And non-examples, we have lots of non-examples of rays now. Point, a line, a plane, a circle. Any of those are non-examples of rays. All right. Any questions about what goes on our deal for our rate? Okay. So now I have a question for you. We're going to name this ray, and I'll draw it in so we can see it a little bit. So here's my ray, and this is point R, and this is point B. So what would be the name of this ray? RB. So we're going to write the letter R and B, and we want our arrow to line up the same way. So we can do it this way. If it helps you remember, put that end point there, so that has to line up there. We can put our other point there. If you want to draw it that way, that's fine. Is that the only way we could name it? I could do this, and that would work also. Either one of those is the name of the ray using proper notation. All right, we good here? All right. Now I need to find a different PowerPoint going here. This is the other questions. The other slides are on this other PowerPoint. The last thing that we're going to talk about is an angle. So our technical definition for an angle is going to be this first part, figure formed by two rays with a common endpoint. So that's going to be your technical definition. So your term is angle, and that's your definition. And we'll draw a picture of an angle down here. So this would be your picture. So there are my two rays. The common endpoint, this is my common endpoint. This is the vertex. So this would go in your factor characteristics, or you could label your picture, the vertex. And I'm going to call this ray, this is A, B, C. So the rays that make up the angle are the sides. The interior of the angle is the space between the rays. And remember, these extend infinitely in all directions. And everything else out here is called the exterior of the angle. So an important fact or characteristic about our ray is we can name them in three ways. We always use our angle sign. That's what this little angle. And we can use 3 points with the vertex in the middle. So notice they named it angle A, B, C. The vertex has to be in the middle. A, B, C. If there's no way to confuse it, we can name it with just the vertex, angle B. Or sometimes they'll put a number inside. We could say angle 2. So those are With rays, I think rays and planes are where students make the most mistakes in terms of how we name them, using proper notation. So make sure the vertex has to be in the middle. We can use the vertex if it can't be confused with any other angle. And if they put a number in here, we could call it angle 2. Don't always do this. This is the most common way to do it. Example of an angle. What would be an example of an angle? Come up, yeah. Yeah, like a compass. When we open it up, it makes an angle. I think of a ladder leaning against a wall, maybe. The corner of the computer is an angle. So those are, what's that? Legs, yes. The hands of a clock or a watch make an angle. So those would be examples of an angle. And we have lots of non-examples now. A point, a line, a plane, a ray is not an angle. A segment is not an angle. So you can put any of those in your sheet. All right. Now I have another question about angles. Are we good with our definition? Okay. And we want to name this angle. And I'll draw on there so we can see it a little better. Let me do this. Here's my... Oops. Let's see. That's A, and this is B, and this is a 4. All right, so let's name this angle. How can we name this angle?
4.
Angle 4, so we use the angle sign and a 4. How else do we name it? Angle, and we could say angle A, okay? So we use the vertex. How else can we name it? CBA, angle CBA. Can we say CBA? CAB, we need the vertex in the middle. Can we name it another way? BAC. As long as the vertex is in the middle. So all of these are named for this angle. So let me ask you another question. I'm going to draw a picture of an angle here. And can I call this angle, can I say angle A?
Yes.
If I have a couple of yeses and a couple of no's. How many angles have A as the vertex? All of them? How many of them are there? 3, right? I have that angle, I have that angle, and I have that angle that all have vertex A. So I can't say angle A because we wouldn't know which one we were talking about. So in this case, because we wouldn't be sure, we would have to say angle BAC or angle CAD or angle BAD. So when a bunch of angles have the same vertex, we can't use just the vertex. We have to use the 3 letters. Or if there were numbers, if this were a 1 and this were a 2, we could say angle 1 and angle 2. But we couldn't say angle A for the big angle because we still don't know if that could still be any of the others. So this is another place to be careful. All right, we good with angles?
Yeah.
Yeah? Okay. Let's talk about how we measure angles. So our protractor is how we measure angles. Our protractor is like a curved ruler. So what you want to do with your protractor, I just want to demonstrate a few. So here's my angle. You can just draw one on your paper. So I'm going to grab my protractor. Here's my protractor. What you want to do is the protractor is always going to have either a little cross or a little point. Some have a little hole right here. You want to put that on the vertex of your angle. And you want to line this line up with one side of the angle. So I'm going to line that red line up with one side of the angle. And then I'm going to go along this scale and read how big the angle is. So it looks to me like this angle is right at 60 degrees. So I'm reading it right here on this smaller scale. So let's do another one. So I'm going to grab my protractor, set the points, the cross, whatever on the vertex. Make sure that the line here lines up with one side of the, come on, there we go, one side of the angle. And now because my angle is bigger than 90 degrees, I'm going to go all the way around here. And this looks like it's just almost 120 degrees, it looks like to me. So I'm going to say that's about 119 degrees. I can also lay the compass along this side of the angle. So let me do one where I do that. So I'll grab here and I'm going to put the compass this way, and I'm lining up this side of the angle rather than on this side. And now I'm going to read on the bigger scale because I'm going the other way. So this looks like it is looks like it's just over 90 degrees. So I'm going to say 91 degrees. And I could also, sometimes they'll give you problems in the book where they lay the compass on like so, and they want you to figure out how big the angle is. What would I do if if you had the compass set up like this? Find the angle. Subtract the smaller one from the bigger one. So I go over here and it looks to me like this is about 149, and it looks like to me that this is about 30. So 149 minus 30. So I'm reading that right here, and I'm reading the smaller number here, and that gives me 119 degrees. And that's just like we did with the number line, where we just counted the spaces. That's essentially what we're doing, is counting the spaces between here and here. So we take the bigger number and subtract the smaller number. So we can do it that way also. All right, questions on measuring. We're going to do an activity a little later that has to do with measuring, so you can practice a little bit with the protractor. Let me get rid of that. So that's how we measure angles. We have some important types of angles. And we see these names come up a lot. It's important that we know what we're talking about when we see these angle types. So what is a right angle? 90 degrees. And when we draw a picture of a right angle, the way that we know from the picture that it's a 90 degree angle is they put a little square there. If in your book it looks like a 90 degree angle, you can't assume that it is unless they put that little mark there. So you can't say, oh, that looks like 90 degrees, I'm just going to say it's 90. Unless you know for sure, you can't say. And they like to trick you by drawing the drawings to look like they're 90 degrees. They might be 89 degrees. They might be 92 degrees. So they try to trick you. How about a straight angle? 180 degrees. So a straight angle just looks like this. And sometimes you'll see it drawn like that. But a straight angle is just a line, basically. How about acute? Less than 90, and we're going to just be a little more accurate and say between 0 and 90. Because we don't want a negative angle. We don't want to say that an angle of negative 10 is acute. So it has to be between 0 and 90. How about an obtuse angle? Between 90 and 180. So we talk about angles. The book will talk about right angles and straight angles. And your book will also talk about opposite rays. Opposite rays just mean two rays that come together to make a line. So one goes one way, one goes the other way, and they come together and they make a line. So those are opposite rays. All right, we good here? Sounded like we had these down pretty well. We use congruent with angles the same way we did with segments. So we're going to say that congruent angles have the same measure, or degree measure. The way we show that angles are congruent, we say that angle A is congruent to angle B. We use the same symbol, it means the same thing. This means that the measure, M means measure, that's how many degrees, measure of angle A equals the measure of angle B. So we use it in the exact same way. And the way we would show it with a picture, we use the tick marks to show congruent angles. So that's how we would show that angle A and angle B are congruent in a drawing. The same number of tick marks means that the angles are congruent. And that also means they have the same degree measure. The little m means measure. So nothing really different here. Okay, we good with this? Last thing we need to talk about today is our angle addition postulate. Angle addition postulate tells us the exact same thing as the segment addition postulate tells us. So I'm going to write it down. It sounds confusing. We'll draw a picture. Not real confusing, but the words are a little strange. We'll draw a picture and we'll talk about what it means. So we have angle, I'm going to call it AOC. And we're going to say B is in the interior. So point B is in the interior. What the angle addition postulate tells us is a measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So let's draw a picture, see what this is telling us. There's point B in the interior of this angle AOC. It's telling us that the measure of angle AOB, I'm going to mark that one. Here's AOB in green, plus BOC, I'll mark that one in blue. There's BOC. Equals the measure of angle AOC. That's that whole big angle. What the angle addition postulate is telling us is I can add the measures of these two smaller pieces and it equals the measure of the big piece. That's all it's telling us. Add the two small pieces, they equal the big piece. Nothing more complicated than that. Okay? So just like with the segment addition postulate, we add the two small pieces together and it has to equal the big piece. So let's look at an example that has to do with the angle addition postulate. They're just like, we worked the problems just like we did the segment addition postulate. So here is my picture. And we're going to say this is 6x minus 5, and this is 4x plus 10, and this whole thing is 175 degrees. So in words, we're saying the measure of angle, and I need to label some pieces, A, B, C, and D. The measure of angle ABC equals 175 degrees. We want to find the measure of angle ABD and the measure of angle DBC. So I'm going to use my highlighter again. So here's ABC, 175, that whole thing. ABD is this one in green, and DBC is this one in blue. So what does the angle addition postulate tell us we should do here? Oops, I forgot to mark my blue.
You actually add the two pieces together.
We add the two pieces together, these two things, and they have to equal 175 degrees. Perfect. Add the two small pieces, they equal a big piece. So 6x minus 5 plus 4x plus 10, and that equals 175. And then we're going to, oops, I forgot my x here. We're going to combine like terms. So 6x and 4x is 10x minus 5 plus 10 is plus 5. 175, I subtract my 5. 10x equals 170 divided by 10. We know how to do this. We're setting our dumpsters on fire. This is a problem we already know how to solve. And we get x equals 17. Are we done? No, what does the problem ask us to do?
Well, you have to add it together so you can plug in x.
We have to plug in x. It's asking us to find each piece. So measure of angle ABD is 6 times 17 minus 5. 6 times 17, 6 times 10 is 60, and 6 times 7 is 42. So this is 102 minus 5, which is 97. Yes? And then the measure of angle DBC is 4 times 17 plus 10. 4 times 10 is 40, and 4 times 7 is 28, so we get 68 plus 10 is 78. And when I add these two together, they better equal 175, so we'll check. 97 plus 78, does that equal 175? And we did it correctly. Check. So there are answers, 97, and we'd say 97 degrees and 78 degrees. So that's all the segment or the angle addition postulate tells us. Add the two small pieces, they have to equal the big piece. Questions? Okay.